Let's get a whiteboard going. A linear function is anything that can be written in the form f of x equals mx plus b. You're not going to have any radicals. You're not going to have any exponents. And you're not going to have any variables in denominators. Because a linear function gives the relationship between the y value and the x value, and this is just the same thing as y equals mx plus b, it's just written in function notation. So if we had something, for instance, like, say, just y equals x, and this is actually called the identity function, where y and x are the same thing. This has points like 0, 0, 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2. If you look at these points, we've got 0, 0, 1, 1, 2, 2, the negatives. Because the x and the y are exactly the same, that means for every point, whatever distance you go to the right or the left, you're going to go the same amount up or down, where right means up and left means down, because they're going to have the same sign. So you actually end up with a line that bisects the first and third quadrants. We can also have a function where y, for instance, is equal to 3. There's no x in the equation. Now, this doesn't mean that you're not talking about something in two-dimensional space with x values. It means x can be anything as long as the y is 3. X can be any value at all, but the y has to equal 3. So it's going to be of the value, any value f for x, 3. So we've got points like 0, 3, 1, 3, 2, 3, 3, 3, negative 75, 3, 2/3, 3. The only rule is the x value, the y value, sorry, has to be 3. So we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. We've got points like over 0 up 3, over 1 up 3, over 2 up 3, over 3 up 3. So you can see a pattern going here. Negative 1, 3 would have y as 3, negative 2, 3, negative 1/2, 3, everything in between. So the graph of y equals 3 is a horizontal line through the 3, on the y-axis, because the y is 3. We could write this in the form y equals 0x plus 3. So this is a function. Now, on the other hand, if we were looking at a graph of something like x equals 5, the only rule here is that the x has to be 5, y can be anything. So we've got 5, 0, 5, 1, 5, 2, 5, 3. This should be enough to see a pattern. So over 5, up 0. 1, 2, 3, 4, 5. Over 5, up 0. Over 5, up 1. Over 5, up 2. Over 5, up 3. You can see that all of these points are going to be 5 over from the y-axis. You go over 5 and then up or down, whatever. It includes all of the fractions and the irrational numbers and everything else. So here we have a vertical line Sometimes this doesn't write. Going through the 5 on the x-axis. Now this is actually not a function. Just to throw this in. This absolutely, completely fails the vertical line test. This is as much of a failure of the vertical line test as you can imagine, because if you draw a vertical line that touches this graph at all, it's going to touch it in every point, an infinite number of points. And notice that this cannot be written in the form y equals mx plus b, because you can't put anything in for the y value. On the previous one, you could put 0 in for x. So y equals 0x plus 3 would be y equals 3. But on this one, there's nothing you can put in that will wipe out the y. And that makes sense because it's not a function. Now, when we talk about slopes, the slope is a numerical measure of how steep the line is. And whether the y values are going to increase or decrease as the x values increase. That makes it sound kind of complicated, but it's not. If a line, we always look from left to right. If a line is going up as we read it from left to right, it has a positive slope. If a line goes down from left to right, it has a negative slope. So the x values increase as we read from left to right. So if at the same time the y values increase, the slope's positive. If the y values are going down, the slope is negative. If it's a horizontal line, recall in a horizontal line, it's just y equals some number. We might call it A. If y is just some number, like y equals 3, then as the x increases, the y is just 3. X increases some more, y is still 3. So the slope here is 0. The x is the increase, the y value neither increases nor decreases. If you have a vertical line, what happens as x increases? X never increases. X never changes. The slope, which is a measure of how steep the line is, this is infinitely steep. We consider the slope to be undefined. Now, the number itself is the rise. They call it the rise over the run. The rise talks about how much you go up or down. The run, consider yourself running. We run along the ground, so the run is left and right. The higher the rise, per x value, basically. The higher the slope is, or the larger the slope is. So if we had this line, the slope is the ratio it's the ratio between the change in x and change in y. Since it's a ratio, it doesn't matter which point you use to calculate it. So if the x from this point to this point goes up, if the y value, if the y goes up this much, and sometimes they'll use the Greek letter delta, little triangle there, to represent the change in y. So it's going from here to here. This amount is the change in X. Same thing here. So the slope, M, is the change in the Y value over the change in the X value. The bigger this is in comparison to this, the bigger a number the slope is. So this is going to have a relatively small slope. It's not very steep. Where a line like this, if we go from here to here, here's our change in our Y value. It's our rise. Here's our change in our X value. So this is going to have a larger slope. We can calculate it numerically by taking the Y values and subtracting them. If we let this be X1, Y1, and this be X2, Y2, then the slope itself is what you get when you subtract the Y values. This distance is going to be Y2 minus Y1. Let me fix that. The distance from here to here if this is X1 and this is X2, that's going to be X2 minus X1. It actually doesn't matter which point you use, because if you reverse your subtraction in the top, it'll change the sign. But if you reverse your subtraction in the bottom also, it will change that sign. So just like a negative over a positive is the same as a positive over a negative, they're both negative. It doesn't matter which point you put first. These have to come from the same point. And these have to come from the same point. So if we want to find the slope, between, say, negative 3.5 and 2, negative 8, we could let this be X1 and Y1, and this be X2 and Y2. And the slope would become Y2, negative 8, minus Y1 is 5, over X2 would now be 2, minus X1 is negative 3. So negative 13 over this 2 plus 3, so negative 13 over positive 5. That means the rise is negative, so it actually goes down 13. And the 5 is positive, so that would be 5 units to the right. Or we could reverse them. Let's say put my parentheses back. Let's say we let this be X1 and Y1, and this becomes X2 and Y2. So now we would have Y2 is 5 minus negative 8. over, now we have to use this x first, so -3 minus 2 becomes 5 plus 8 over -5, which is positive 13 over -5. Now this could now be considered a positive 13, so up 13 over your horizontal is going to be -5. So this would be 5 units left. Well, let's kind of take a look at these points. -3, positive 5 is about here. Positive 2, -8 would be about here. So this line is going like this. Definitely has a negative slope, fairly steep. Basically anything bigger than 1 would be a steep slope. 13 over 5 is definitely bigger than 1. And you can see that we can either count down 13, from here to here would be 5, and then here more, this would be 8 more is 13. And then from -3 to 2 would be 5. So if we go down 13, that becomes a -13 over a positive 5. Or if we went up 13, make it the same distance, and back 5, so if we did a positive 13 and a -5, we'd still be on the line. So these are the same. -13 over positive 5 is equal to positive 13 over -5, both of which is just equal to a -13/5. That's how we calculate the slope. The slope of a vertical line is undefined. The slope of a horizontal line is 0. A line that goes up is going to be positive. A line that comes down is going to be negative. Let me know if you